Okay, last but not least, the last type of discrete distribution that you're going to look at is hypergeometric distributions. So these are probability distributions with dependent trials whose outcomes are either success or failure. So much like binomial, except for these are dependent trials. So the random variable is the number of successes in a given number of trials. So this is what the formula looks like. So the probability of x is going to be a choose x times n minus a choose r minus x over n choose r. So this is going to be, a is going to be the number of successes available, n is going to be your population size, and x is going to be the number of successes, and r is going to be the number of trials. Again, it'll make more sense once we do a couple of examples. Okay, so the first example. A committee of 6 people is to be formed from 6 grade 11 students and 7 grade 12 students. Determine the probability the committee will have 2 grade 11s. So this time we need A, N, X, and R. So A is the number of successes available. In this case, success is grade 11 students being on the committee. So A is going to be 6 because there are 6 grade 11 students. N is the number of trials. So we actually have 13 students total to choose from. So we're going to have N is going to be, the population size, not the trials, the population size. So we have 13 students total. So that's where N is going to come from. X is the number of successes. So we want 2 grade 11. So X is going to be 2. And then R is the number of trials. And that is going to be 6 because we're choosing a committee of 6 people. So now that we have all of our values, we're just going to, just like before, we're going to plug them into the formula. So the probability of x being 2, not 6, the probability of x being 2 is going to be 6 choose 2 times 7 choose 4 over 13 choose 6. And this should make sense to you because what we're basically saying is we're saying we want 2 grade 11 students. So we want to choose 2 out of the 6 grade 11s, which means we need 4 out of the 7 grade 12s in our committee over, we're doing probability, remember, so over 13 choose 6. And you would have done things like this in the probability unit. You just didn't call it a hypergeometric distribution, but that's exactly what it is. So if we were to plug that into our calculator, then we would get 0.31, which means there's a 31% chance that if you were to randomly select a committee out of the 6 grade 11 and 7 grade 12 students, there's a 31% chance that you would get 2 grade 11s, exactly 2 grade 11s on the committee. Okay, let's look at another one. 5-card hand is dealt from a standard deck of cards. We want the probability distribution for the number of hearts in a hand. As soon as you see the word probability distribution, you should know that you have to do a chart. So our chart is going to say X, which is the number of hearts. And then P of X. And then off to the side, let's figure out all of our values. So we have A, N, X, and R. So A is the number of successful things available. Remember, success is getting a heart. So there's 13 hearts in a deck, so it's going to be 13. N is the number of total population, so there's 52 cards in a deck, so N is going to be 52. X is going to be number of successful outcomes, so that could go anywhere from no hearts to 5 hearts. So everything in between. And then R is 5 because that's how many cards we're drawing or dealing out. So X is going to be either 0, 1, 2, 3, 4, or 5. And just like before, we'll have to do the formula a whole bunch of times. So I'm just going to do it once, and then I'll just put in the rest of the answer. So it would be 13, choose 0, times 39, because there's 39 non-hearts left, choose 5, over 52, choose 5. And that would be 0.22. Okay, I'll do one more and then I'll just fill in the rest. So 13, choose 1. We want 1 heart, which would mean that we would choose 4 of the 39 other cards over 52, choose 5. And that should equal 0.41. And if you continue in that pattern, you would get 0.27, 0.08, 0.01, and 0.005. So that should be your probability distribution for the number of hearts in a hand dealt out. Expected value for a hypergeometric distribution is RA over N. So in this case, R was 5, A was 13, and N was 52. So you would be expected to get 1.25 hearts in your hand. And we'll just do one example. So last one. In a class of 30 students, 18 have a driver's license. 10 students are selected at random, and we want to know the probability that at least 4 have a driver's license. So in this case, our A value is number of successful outcomes. Success is having a driver's license, and there's 18 students who have one, so that's going to be success. N is the total population. There's 30 students total. Now, in this case, X is going to be, we want at least 4. So again, we could do 4 plus 5 plus 6 all the way up to 30. That's going to take forever. So let's not do that, and let's do 1 minus less than 4. So X would be 0, 1, 2, and 3. And R would be 10. So if we want the probability that X is greater than 4, it's going to be the 1 minus the probability that X is less than 4, which is going to be 1 minus 0 people with their driver's license minus the probability that 1 person has their driver's license minus the probability of 2 minus the probability of 3. So it is still kind of a lot of work. So you'd have to do 1 minus 18, choose 0, times 12, choose 10, over 30, choose 10, minus 18, choose 1, times 12, choose 9, over 30, choose 10, minus 18, choose 2, times 12, choose 8, over 30, choose 10, minus 18, choose 3, times 12, choose 7, over 30, choose 10. And you can put that all in one if your calculator will let you, or might do it separately, but you should get 0.98. So there's actually a 98% chance that at least 4 of the students that you choose out of the 10 have a driver's license. And last but not least, expected number of students with a driver's license. We're going to use our expected value formula, which is RA over N. So we're going to do 10 times 18 over 30, and we would get 6. So you would expect that 6 of the students that you randomly picked would have their driver's license. And that is hypergeometric.